Investigate horizontal transformation. Here's a very interesting question for you, and at times I've seen students making mistake in this. So what you need to do is to be very careful and see how I do it. Now, here the question is, describe the transformation and sketch the graph of each transform function. So we have three transfer functions here. I will do one of them for you and leave the other two. Now, this time I will do absolute function. Now in this, g of x is given to us as half of x plus 2. Now you need to write down or describe the transformation of this function and then sketch it. So let's start writing transformation for this function. It is g of x equals to absolute value of half. So in these kinds of functions, what we do, first step we always do is we should factor this half. If you don't do that, then you get wrong results. So I'll factor half here, and once I factor half, I get x, and what do I get there? You got to multiply by 2, so you get 4 here, right? So that is the real function which is given to you. You'll notice, if you open the brackets, you get half x plus 4 divided by 2 is 2, the same thing. Some of you must have noticed now that writing like this saves you from making an error. If you don't factor half, then what will you write for this 2? You will say this is horizontal translation of 2 units to left, but actually it is not 2 units. It is 4 units left. So this is a common mistake which I've seen so many times. So that is kind of critical. Here also one can make a mistake. So you need to factor 2 out. So once you write 2 outside, then outside means, let me do that for you. So we have to write within square brackets, factor 2 out, and you get x. What will be left? 3, because 6 divided by 2 is 3. So this is what you will get for the function. And do you need to factor this? Think about it, right? Think about it. But I think the answer should be, you have to factor, this is minus 1, and then that becomes x minus 1. So this is the first and foremost step in all these functions where there is a coefficient of x which is not 1, whether it is minus 1 or half or whatever. You need to factor that and then look into the function. So now it is horizontally translated 1 unit to the right, not left. Do you understand? And this is translation of 3 units to the right. So that makes a huge difference, correct? So that's the first correction, and it is mainly because of this that I took this example. Now, what we should do is, we can write down the critical points on our parent function. So parent function here is absolute function, which you all know. So what I will do is, I'll just plot absolute function here. So start with your vertex. You know, it's 1, 1, 2, 2, 3, 3, 4, 4, like that, right? And it is symmetric about the y-axis. So just draw it, and you can connect them with a line. So it is a straight line, y equals to x in the first quadrant, and it is y equals to minus x in the second quadrant. And this graph, you know, has a vertex at origin, and it is symmetric about y-axis. Now we will do with the help of transformation. Now transformation here is, let's understand, first transformation we will go from left to right. When I say half of something, right, it is inside the bracket, k value is half, and therefore we say it is horizontally stretched. By a factor of 2, right? So half reciprocal is 2. So that is the first thing. And second is 4 units left, right? So translate 4 units. I mean left. So that is the transformation which you have for this function, right? So if you do these two transformations, then you can get the result, right? So that is how it is. Now what we can do is, graphically, what we will do is horizontally stretch by a factor of 2. That means these points will go away outside twice the value. It is at 1, so it will go 2 units. So this will come here, 2. We can select this point, 1, 2, 3, 4, 5, 6, 7, 8. So this point is going to land here. Do you see that? So like that, all these points are going to go twice the distance away. So the whole idea here is that it will give you like stretch horizontally, so it become more and more flatter. So here also we'll have these points. So like this, it is 1, 2, 3 units, 3 more. So it gets stretched. So let me draw the first part of it, which is saying horizontally stretch by a factor of 2. So it looks like vertical compression, right? Now, since it is within the brackets, inside the function, it is always horizontal. So don't go for vertical at all, correct? That is a precaution you should always take. So this is the first step, and let me write down what I've done here. So this one is my function, which is absolute half x. So I've done half the job. This is the original function. Now the next part is to translate each and every point 4 units to left, right? That is what? So you start with vertex. 1, 2, 3, 4. You come there, right? So vertex we have done. Now you can take one point on the side, right? Now you're on this blue line, correct? So we have done 1, and this point 1, 2, 3, 4, that goes there, and this point 1, 2, 3, 4, it comes here, right? So what we can do is join these two. We can take more points, and let's take this point. So it moves 1, 2, 3, 4, 4 units. And let me take a point which is kind of here, because I don't want to run out. 1, 2, 3, 4, okay? So we are moving this point 4 units outside. Do you see that? So that is what we are doing. Every point is moving 4 units left. So from this vertex, if we go 4 units left, we get our final drawing, and that is this function. So graphical solution is actually the best option here. It's a very good option for any graph for that matter. So now we get our function, which is g of x. Do you see that? So that is how we can get g of x. Now as a test, what you should do is check with your points. So the original points on the function are, as you can see, the transformation here is from xy to horizontally stretched by a factor of 2. So you get to multiply x by 2. So you get 2x, and we say translate 4 units left, that means take away 4. So that becomes x, change in x point. So every image point will be transformed in this fashion. Y remains the same, right? So if we have a series of original x points as, let's consider 0, 0, 1, 1, let's say minus 1, 1. Let's consider these 3 points just to check. Then x values get multiplied by 2, then minus 1. So if I multiply minus 1 by 2, I get minus 2, and then minus 4. So minus 2 minus 4 gives me minus 6. So this becomes minus 6, and the y value has to remain same. Y value same. 0. 0 times anything is 0. So we get minus 4 and 0 here. That is a change in vertex. And 2 times 1 is 2, and minus 4 gives me minus 2. So I get this point as minus 2, 1. Now let's check. That is the vertex. 1, 2, 3, 4. So that is minus 4 for me, and it is at 0. So that is correct. Now 6. That is minus 6 for me. I'm at 1. That is also correct. Minus 2. This is minus 2 for me, and that point is 1. So it is always a good idea to plot your points and then check. Now in most of the questions, you will be asked this question. That is, list 3 points on transform function, right? So we can sometimes we write transform function or on the given function, right? Because in this case we are given the function, or sometimes we use the term image, right? So all these terms are kind of similar. Anything could be written as list 3 points on, let's say, the given function. So once you do, you give 3 points and check your result. The whole idea here is for you to check the result, right? And last question which I'll add here is write domain and range for function, let's say for given function. So when you do these kinds of exercises, see, we are preparing for the test, so try to get most of what you have here. So write down domain and range, try to understand how the function is transformed and how really it affects all other things. Thanks and all the best.